Hi everyone, welcome to Going from Zero to App with MongoDB Realm in minutes. My name is Sumedha Mehta and I'm a product manager on Realm. So let's talk about mobile apps today. Just recently, I was on the New York subway and I found an interesting article on the Medium app. However, right when I saved that article, I hit some pretty spotty internet underground. Instead of throwing an error on that save, or even worse, throwing the save out, Medium said, hey, I can actually store your save locally and then send it to the cloud when you have better connectivity. This is a phenomenal user experience where an app is reactive and also performs offline sync, which is important in a world that's becoming mobile first and data integrity is crucial. However, as someone who's built offline first syncing from scratch, I know that it can get really hard to deal with complex networking logic with regular REST APIs. So today, I'm going to show you how to add MongoDB Realm's sync solution, which is out of the box, into your app so you can build resilient and real-time apps quickly. I encourage you to watch the keynote and read our docs to understand the breadth of Realm's services, but today we'll primarily be working with Realm's local database and Realm Sync. My app will be a simple iOS app that stores the location of important places that I want to remember, or pins. We'll start by looking at how we can store this data in the Realm local database instead of in memory, so data is persisted across any app cold starts. After that, I'll show you how to add on data sync to your app, so pins and their coordinates can be synced in real time to any other device that has that app installed. Since this is a lightning talk, I'll be explaining the high-level concepts that you need to keep in mind when you begin adding the syncing service to your mobile app, and my demo will be quite basic. I'll be using the Swift SDK for reference, but note a lot of steps and concepts can be applied throughout other SDKs and frameworks. Let's get started. So there are 3 steps we need to take to get the local database to store data. You heard me right, just 3 steps. The local database makes it incredibly easy to store your data because it lets you store data as objects, which is how a lot of us are used to working with data on mobile apps. So the first thing we do is we install the SDK and import it into our app. Pretty straightforward. The next thing we'll do is we'll inherit the object class for whatever object we've defined and would like to store. In this case, this is a simple pin object which consists of a string and 2 doubles. I've also added the Objective-C attribute to the object so it can be accessible from the underlying database, which is a Swift-specific detail to keep in mind. And the final step is to persist data to the database. Here, I've shown 2 small snippets of my code where I was originally saving them to an array, but now I'm instead storing them to the Realm database by simply opening the Realm default database. And from here, we've achieved rudimentary reading and writing to the database, which persists data across any future cold starts. Cool, so we just got done with adding data to our local database. Let's learn about how we can add on our syncing service. So data can be stored in your local database and then get synced automatically to the cloud. This is where the magic happens. Just like setting up a local database, enabling sync only takes a few steps. The first part will take place in the MongoDB Realm admin UI, where we'll enable sync, and then we'll make a few changes to the client-side code, so we can finally get our database on our local device to start syncing to the cloud. For brevity, I'll assume that you already have a MongoDB Cloud account. So on the cloud side, there are 2 major cloud services we need to set up before adding sync. Authentication, which allows us to store data about our end users, and schema, because Realm requires a strict schema in order to sync data from your Realm objects to your device on the cloud. Developer mode is a setting on Realm that automatically sets both of these up and is a great tool for getting started quickly. Once you're done developing your app and you're going into production, just make sure to turn this off. The best part about developer mode is that you can set it up in just a few clicks. Assuming you've already created a MongoDB Cloud account, we'll simply go to the Realm app page and create a Realm app. And then from there, we can enable sync with development mode. We can choose our Atlas cluster and the database name, which is where our data that is being synced will be stored, and we'll also define a partition field name. For now, let's call this _partition, and I'll get to what this means in a little bit. And finally, before we move on to the client-side changes, the last thing we need to make sure of is that we deploy our changes. So going back to the client side, we'll first add the Realm package. This will expose the API that lets us use the cloud aspect of MongoDB Realm. It's pretty straightforward again. Next, we'll initialize our app. The Realm UI console displays our app ID on the dashboard, so we'll just take that and copy it on app start. Now our client app knows which cloud app to start making requests to. But we can't read and write data just yet. Remember how I said Realm Sync requires authentication? We can start by adding simple anonymous login flows right after initializing our app, which dev mode already set up for me on the cloud side. You can always go back and add on other providers that are more secure, like email password and Google OAuth later, but that's out of the scope for this talk. Now it's time to open our synced Realm. Previously, we had opened our default Realm by initializing it in our view controller class. So we'll need to change this so data is now stored in a Realm database that can actually sync to the cloud. We can do this by changing the reference to the Realm database from a local realm to a synced realm by using the following async open syntax and passing in a configuration with the partition and the current user. Now is a good time to talk about partitioning. As you can see, I'm opening all of the Realm databases with the public partition key, which means that all documents can be read and written to by anyone who opens the app. As I mentioned earlier, I'll be sharing my pinned data globally. That means my permissions are global and any user of the app can open and see my data as well as write to it. However, for more advanced apps, this can apply to other attributes as well. You can selectively partition and sync data based on the attributes like user identity, whether your app has Gold or Platinum edition, a certain app OS, or project and team names. If you're interested in learning more about partitioning and partitioning strategies, there are a few great talks and articles out there on our developer hub. So just to reiterate, you can see that my Realm database now has been opened up with a specific partition and user associated with it. This means that the local database is now going to take everything I store in it and sync it back to the cloud. We do want to actually leverage the real-time aspect of sync here as well, which is why we'll need to add a notification token upon opening our Realm. This is as simple as adding another small function where we successfully initialize our Realm sync database. The function will set a class variable that lets us observe changes on certain objects. We can then set up handlers on what will happen when changes are successfully synced from the cloud or potentially other devices. In this case, I'm updating my UI or my table view to refresh the data when that happens. Finally, don't forget to invalidate the notification token when you no longer need to listen for changes. One place to do it would be when the view disappears. And lastly, right before we run our app, we also want to make a few tweaks to the pin object. This is so our local data matches how MongoDB expects a document schema to look like. When we were only using the local database, we had originally defined our pinned object like this. It had 3 fields, a description, a latitude, and a longitude. When we add on sync, we'll have to make sure that we add an ID field and override its getter. This is because MongoDB documents require an ID field on each document, and now our object model is compatible with MongoDB's document schema, so we can run our synced app. So today we learned how to build a mobile app with syncing capabilities in just minutes. I hope that you give it a try and realize that working with data on mobile apps doesn't have to be that hard. Thanks.